Okay, let's talk about the project. Project 1. Yeah. How can we answer this project? Do you need some time to read through the project? No? No? No?
You said, did anybody have time to read through it?
Yeah. Do you need some time to read it? No? Okay. So we can go directly to the project, to the solution? Okay. Let's talk about the solution. First, we want to list the known information in the Excel, right? Let's copy this form. And then open an Excel file. You can choose any cell to paste the known information, anywhere. Let's choose C4. Let's paste the table into C4. Let's make it nicer. Yeah. This table shows how long it will take for each candy bar go through each machine. We have 4 machines, right? Yeah. It shows how long it will take for each machine to process each type of candy bars. Yeah. This is one collection of known information. Another collection of known information is what? Yeah, it's profit, is the price and the variable cost per candy bar, right? Yeah, let's go back to here and then copy this table. Let's select this table. Go back to Excel. In the section below, let's find some area to paste this variable. Let's choose C15 and then paste this table. So we have 2 tables, right? Yeah, there are no information. What is the goal of this question?
To find the maximum revenue.
Yeah. From the financial investment perspective, what we want to do in this question is to maximize the margin profits, right? Yes, very good. Yeah, obviously we have finance major in this classroom. Yeah. What is the margin profit? You use price minus variable cost. Yeah, that is the margin. We want to maximize the margin. Yeah. So let's find a cell. How about M4? Making money for this company, right? M4. Total margin. In N4, obviously that will be the objective cell, right? That holds the objective function. Let's change the background color of N4 to yellow to indicate this. How can we calculate the total margin? We have to calculate the margin for each type of candy bar. Multiply the amounts of candy bars we want to manufacture in each type, right? Yeah. Let's do this. Margin per bar. Let's go to cell C19 and then type in a label, margin per bar. And then in cell D19, let's type in equal sign. And then we use D17 minus D18. That is the margin we can get from a whole nuts bar. We can drag the autofill button of D19 to E19, F19, G19. This is the margin from each bar in each type. Yeah. We already know the margin per bar. Next, we want to identify the decision variables. Yes. How many bars we need to manufacture for each type, right? Yeah. Let's find a position to hold the decision variables. What about cell C11? In cell C11, let's type in expected amount. So in cell D11, E11, F11, G11, this will be the decision variables. which are the amounts of bars we want to manufacture in each type. Yeah. Let's change the background color to light blue. Light blue. How can we calculate the total margin? We know the margin per bar. We know the expected amount. Yeah. Yeah, we use margin per bar, multiply the amount of bars we want to manufacture in each type, and then add these multiplications together, right? Yeah. In cell, yes, sum product. In cell N4, let's type in equal sign, sum product. We want to choose two ranges. First, we want to choose margin per bar, D19, colon G19, and then a comma, and then select the decision variable range, which is D11, colon G11, the ending parentheses, and then press enter. This will be the objective function. Yeah. We already know the objective cell, we already know the decision variables. Now we need to look at the constraints. G, do you have a question?
No, did you use the gross profit as a part of the subproduct?
Yes, that's a gross profit. Yes. Yeah. Which is the margin. Yeah. If you want to calculate net profit, you have to use margin minus fixed cost, right? In our case, we didn't consider fixed cost. We just consider the margin or gross profit. Next, we need to consider the constraints, right? We have a lot of constraints. Let's go back to the project. Yeah, at least 1,000 pounds of the whole nut product. Between 400 and 500 pounds of cluster product. No more than 150 pounds of crunch product. And no more than 200 pounds of roasted product, right? Yeah. Let's list them into the Excel file. Let's find a cell. Let's find a J4. J4. Let's type in constraint. And then in cell K4, let's type in capacity. Capacity. For the whole nut product, the capacity should be at least 1,000, right? Let's take a look. At least 1,000. For the cluster product, between 400 and 500. So we just list the two limits into the Excel file. In K6, type in 400. In K7, type in 500. Nothing special. Yeah. It's just an application of the general optimization analysis. For the crunch product, no more than 150, right? Type in 150. And then for the roasted product, no more than 200. Yeah. This is the capacity. Have we considered all the constraints?
Yeah.
Not yet, right? Yeah, not yet. Let's go back to here. The ingredients, right? We have to consider the ingredients. Yeah. For the whole nut product, it consists of 60% of macadamia nuts, and then obviously 40% of chocolate. Yeah. And then so on and so forth, right? Yeah. Let's find a cell to list this constraint. How about cell C12? Yeah. Let's type in chocolate. And then in C13, type in nut. For the whole product, whole nut product, 60% of nuts, right? 60%. Obviously, chocolate 40%. Since the title is here, right? Whole nut, so corresponding to whole nut product, we list the ingredients of whole nut product.
Can we take it in decimal as in it would be easy?
Yeah,
Like
yeah.
calculations?
Yeah, obviously, yes. You can use 0.4, 0.6 here. Yeah. Or you list 60%, 40%. Doesn't matter. It doesn't influence the result. For cluster products, 40% of nuts. Obviously, 60% of chocolate. Right? Cluster product.
80 and 20.
Crunchy product should be 80 and 20.
Right, one.
Yeah, crunchy product. For crunchy product, nut should be 20%. Chocolate should be 80%. The question stays like this, but in practice, if you want the candy bar crunchy, you should put more nuts, right? Yeah. And then for the roasted product, 100% for nut, and then for chocolate, 0%. Yeah. Here we need to calculate a constraint. The constraint is the company has 1,100 pounds of nuts and 800 pounds of chocolate, right? Yeah, let's list them into K10, K11. These are the constraints, the limits. How can we calculate the two constraints? Do we have to calculate it? Yes, right? Yeah. In cell J10, we want to calculate the total usage of nuts, right? How can we calculate this total amount?
Expected amount into the chocolate.
Yes, very good. Expected amount in each type. Multiply the percentage of nuts for each type, right? Add those numbers together. So in cell J10, let's type in equal sign and then type in sum product. We need to select two ranges. First, the blue ranges, D11 to G11, right? Comma. 1,100 should be nuts, right? So we need to select cell D13 to G13, and then the ending parentheses. We do the same for J11. Let's type in equal sign sum product, and then the blue range, and then the percentage of chocolate. We are in D12, G12, right? Press enter. The numbers in these two cells should be less than or equal to, the number on the right side. Yeah, very good. Have we considered all the constraints? Yes, very good. The available time for each machine, right? No more than 60 hours, right?
60 hours
For every machine, yes, very good. Yeah. Let's select cell H5. Total usage hour. Total usage time. Yeah. And then in cell I5, let's type in capacity. The capacity for each machine should be 60 hours, right? If you change the hours to minutes, should be, very good. 3,300 for each machine. 3,600, right? 3,600 for each machine. So you have to select the autofill button of I6 to I7, I8, I9. Here in H6 to H9, we have to calculate the total usage time, right? the real usage time on each machine. In H6, let's type in equal sign and then sum product. We need to use the expected amount to multiply which one? Yeah, the time on Howling machine, right?
Yeah.
So it should be D6 to G6. Press enter. And then we can make the calculation easier. Because the expected amounts are always in range D11 to G11, right? So we can change D11, G11 to absolute reference. Let's select D11 to G11 and then press the F4 button on your keyboard to change this to absolute reference. Press enter. And then we can drag the autofill button of H6 to H7, H8, H9. This is real usage time, total real usage time on each machine, right? Yeah. Are we ready to calculate the final result?
Yeah.
Yes, right? Yeah, we have considered all the constraints. Next, we need to go to Data tab and then click Solver. Let's choose the objective cell. It's in N4, right? Choose N4. And then we want to maximize this value. Then let's choose decision variables. They are the light blue range, D11 to G11. Next, we want to add the constraints. Yeah. Let's add the constraints. First, the expected amount of whole nut product should be at least 1,000. Yeah. So let's choose cell D11. This is the expected amount of whole nut product. This value, yeah, no matter what the value is, it must be greater than or equal to. So in the middle, choose greater than or equal to 1,000. Yes, very good. Press enter, and then click OK. Next, the expected amount of cluster product should be less than or equal to 500, but greater than or equal to 400, right? Yeah. In the middle, choose greater than or equal to, and then the right-hand side value should be 400. Click OK. And then we add another constraint. The cluster product cannot exceed 500. Less than or equal to, the constraint should be 500. Click OK. Next, the crunchy product cannot exceed 150. Yes. Let's choose 150 as the right-hand side value. Click OK. Next, click Add. Yes, very good. The roasted product cannot exceed 200. Click OK. And then we need to add the constraint for total amount of raw materials, right? Yeah. Yeah, click Add. In the left-hand side value, let's choose cell J10, J11. Less than or equal to K10, K11, right? Yeah. Click OK. This is the constraint on raw material. Next, we have available time. Yes. Click Add. The left side hand value should be H6 to H9. Less than or equal to, yeah, I6 to I9. And then click OK. Also, we want to check the box before non-negativity, right? And then solving method should be simple LP, linear programming. And then click solve. Congratulations, solver found the solution, and then click OK. Now you can see, according to the current constraints, according to the objective function, the maximum gross profit should be $2,913. As you can see, the value in N4. In order to achieve this goal, we have to produce 1,000 pounds of the whole nut product, 500 for cluster product, 80 for the crunchy product, 200 pounds of the roasted product. These are the solutions to this question.